network types and technologies, basically. So we start with the content now. We are going to define computer networks. So they are an interconnected collection of autonomous computers. Collection means a number of computers are there. Interconnected means, first is why we are interconnected them. The purpose is to support the exchange of information so that the computers are able to exchange information. Computers here means users are sitting on the computers and they are working, so they are able to exchange information. Second aspect is how they are interconnected. So they are interconnected through various types of media. We have copper wires. In this, we have twisted pairs and coaxial cables. We'll talk about these in the second unit. Then we have optical fibers. Here, transmission takes place in the form of light signals. Here, transmission takes place in the form of electromagnetic signals. Then there can be wireless connections also. That is, the media will be the air. And the last term is autonomous. Autonomous means every computer is going to work independently, means it is not controlled by any other computer. So there is no master-slave relationship. Why we are particularly mentioning this thing? Because before having these computer networks, we had the concept of mainframe computers. Probably you might be knowing it. And in a mainframe computer, there was one single computer, which was the main computer. And the users were connected to that computer using terminals. So terminal, the difference between a terminal and a workstation. Now in a computer network, we have workstations. We are working on workstations, sort of workstations, where we have the output device, we have the processing unit of the computer, main computer, we have some input devices, we have some output devices like the monitor, we have got these speakers for amplifying the sound, we have the keyboard also working as an input device. In a terminal, you have just an output device, which is the monitor, and the input device, which is a keyboard. It can be mouse also. So here the user does not have its own independent processing unit like it is there in the workstation. Okay, so here all users are connected to a single computer, which is known as a mainframe computer. So there they have a master-slave relationship. Main computer is working, everybody is working. If the main computer stops working, all the work of the users will come to a standstill. So dependency on the mainframe computer leads to this relationship, master-slave relationship. So autonomous now in computer networks means there is no master-slave relationship. Every user is working independently, but at any time, if the user of 0 and 1, so 0 is transmitted, 1 is transmitted, 1 is transmitted, and so on. So again, we will talk about it in the second unit. And this exchange of data is again between any two devices at any particular time. And this communication will be in the form of signals. And these signals are taking place over a cable. So we have hardware as well as software that is involved in the sharing of the data. So this is a data communication system. We have the source who is transmitting the data. We have the destination computer who is receiving the data. And at the source, we have a transmitter. At the destination, we have a receiver. So this transmitter is performing the function of creating signals. Okay, it can be a network interface card. It can be a modem if it is a wide area network. Okay, so we'll be talking about these components in second unit again. And then we have this transmission system, which is a network. Okay. And I hope you must be knowing that our PSTN, Public Switch Telephone Network, that also acts as a platform, is providing infrastructure for the communication of data over a wide area. Wide area means it can be the whole world. It is rather the whole world. Okay, so we are able to, as we are able to communicate voice, we are also able to communicate data. Now, goals and applications of computer networks. So, what are the goals? Why computer networks were developed? What was the purpose? Second thing, for what applications they are being used. So, first is goals for companies and organizations. So, initially, when they were developed for companies and organizations because the commercial importance of computer networks was identified. At that time, individuals like us, normal people, they were not aware of this thing, plus they were not actually working on computers. General population that was not working on computers. So the goals or objectives were identified for companies and organizations. First thing was having a fast means of sharing and transfer of data and information. So earlier, how if suppose a company has its offices, regional offices, one is in India and the other is in suppose in USA. Okay, so it's a multinational company and data has been generated in India and that has to be shared with the head office located at USA. So how it was done? Earlier we had secondary storage devices and in the very beginning, the most common device for secondary storage was used was a floppy disk. So data was stored on that and physically it was transmitted or transferred to the other location. But with now there was a requirement that the data should be shared as soon as it is generated. We need to share it with the higher authority so that timely decisions can be taken from that data. So for that, fast transfer was required and a computer network was identified as the base or platform which can provide this objective, which can fulfill this objective. Second was cost effectiveness. Now, if you might be aware about these mainframe computers, the cost was in lakhs. So a good mainframe computer was defined according to its capability in terms of the memory as well as in terms of its processing speeds. Okay. And with mainframe computers, another aspect was how many users can it get connected to itself. That depended upon the number of ports that were available. So the more the capability of the mainframe system to look into the requirements of more number of users, the more costly it was. So cost was in lakhs, 20 lakhs, 30 lakhs, 40 lakhs. So it was a very costly affair. And then, of course, dependency on that central device was there because if that central computer fails, every work will stop. So with computer networks, we had cost effectiveness in the sense that now we have the same workload that was undertaken by one frame could be undertaken by 10 low cost computers and desktop computers at that time. They were in the range of 50 to 60,000 per computer. Okay. So it would go up to the cost of maybe 5 lakhs or maximum 10 lakhs. And also it provided reliability. Means if one computer in the network goes down, it's not going to affect the operation of other computers. So more reliability was there. Fast access was there because now computers are connected to each other through a media and we do not require any secondary storage to store then take it out like a pen drive or maybe a floppy drive at that time, and replace it and put it in the other computer and then transfer the data. So because of the direct connections, it was very easy to transmit data in a minimum time. Somebody is sending some message. Okay. Then we have scalability. Scalability is how easily we can expand the system. So again, with mainframe computers, if the capability of one mainframe is exhausted, means it can accommodate suppose 10 users, and 10 users are already connected, but now the organization is expanding and now more users are required to be connected to it, then you will have to buy one more mainframe. And buying one more mainframe means again the cost will go into lakhs. But with a computer network, one extra user easily connect the computer to the network. Another user connect the computer to the network. Okay, one more, one more, one more. So that provides a very easy and low cost solution for scaling the network in terms of the number of users. So capacity can be increased very easily. And now also you might be seeing, if I want to have an internet connection easily, I can on my phone or on my computer, I can have on my phone, I can have the mobile data service. On my computer, I can have just, there are service providers in the city. I can have one connection from one of the service providers. So nowadays we are opting for the fiber to the home connection. So I can have one connection installed, and within my home, I have the Wi-Fi system, means my router is equipped with Wi-Fi, and I can have the internet connectivity on all my systems. So the scalability has become very easy, means adding more number of users has become very convenient. Now these are the applications, how individual people are individual. They may be individual people, or they can be the employees or people associated with organizations. So first is we will categorize these applications into three categories. First is access to remote information, then person-to-person communication, and then interactive entertainment. So access to remote information, we all know the World Wide Web nowadays provides access to huge amounts of information. It's a big repository of data, and the data is stored on servers, all connected to the internet. Internet is connecting the whole world, and hence it is connecting us as individuals also. And any information that is located anywhere in the world by using the service provided by World Wide Web, means the protocols which are used, the browser, etc. So with that kind of communication facility, we are able to access any kind of information whichever we desire, provided its security is open. Security is open means it is open for access to any user. Okay, it's not secured with authentications, or it is not secured with encryptions. तो सिक्योर नहीं होना चाहिए. अगर सिक्योर किया हुआ होगा तो हमें फिर पासवर्ड वगैरह, फॉर एग्जाम्पल फॉर कनेक्टिंग टू दिस Zoom meeting, I have been provided with my user ID and password. So that means the system is secure. ऐसे ही नहीं कि कोई इसको join कर ले. So that is the security aspect. Authentication, basically access control to a software. Then we also have e-commerce, through which we are doing online banking, we are doing shopping, we are having access to news and other kinds of information, a vast range of information. Then with person-to-person communication, we have video conferencing, email and messaging facilities. Through WhatsApp, nowadays we message, there are other platforms also. Video conferencing, this is one example of video conferencing which we are having now. This is for online distance learning, okay. And email, of course, we all know we can send mails, means letter content which earlier we used to send in letters, posting them through the post office. Now we are doing it in real time, means immediately on a computer. Then interactive entertainment, we have gaming, we have social connectivity. You might be working on, might be having those Instagram and Facebook accounts and working on that, so on and so forth. Then you have content distribution systems like your OTT platforms, Netflix, YouTube, etc. You have access to digital books. You have these social media platforms. You have online courses like Coursera, Udemy, etc. Then esports, you are getting continuous updates. You have cross-cultural exchange. Whatever you can think of nowadays, as I think, whatever we can think of, we are having it on the internet as a service. Next topic is transmission technologies, which is one of the design issues for computer networks. And it also contributes in the categorization of network. So before doing that categorization, we need to look into the transmission technologies. We have two technologies, two transmission technologies. One is point-to-point, other is multi-point. This point-to-point is also known as store and forward or switch technology. So all these three represent the same thing. Point-to-point, store and forward, or switched technology. And the other is multi-point, which is also known as broadcast transmission technology. So wherever I will refer it again, I'll refer to it by this term, broadcast transmission technology. Okay. And this I will refer to as point-to-point technology. Sometimes I might also call it store and forward. Okay. So this point-to-point technology is mostly used in wide area networks. We are going to take up two categories, local area networks, wide area networks. Apart from personal area networks are also there, metropolitan also there, but the broad categories are LANs and WANs. Okay, so in wide area networks, we have this kind of a connection. Basically, this transmission technology means how we are connecting the computers together. So here there is a point-to-point connection between the computers. So in actual, this is what point-to-point is signifying. Okay, this diagram. In actual, it is like this, a switched network. So difference between transmission and switched transmission. So there is a switch transmission is general, where transmission is taking place between any computers, and switch transmission is this, what I'm talking about just now. Okay, so I think like in the in between when I get the message, I am switching on the message because it is the first class. Otherwise, later on, I will look up into your queries at the end of the session. Else, I may not be able to finish the syllabus on time. So a switched network. Switched network is switched or point-to-point transmission technology is one which is followed in a large area where it is not possible to connect every computer to each other directly. So it's not possible to connect the computers directly. Okay, so here the connection is between a computer and a switching element. In the internet terminology, we call it a router. Okay, they can be routers, they can be gateways also. So we'll take up the difference in the second unit. So this is a general term, switching element, and particularly it's a router in internet terminology. So this makes, as it is in the case of telephone system, this makes up a subnetwork. So this is a network in which a number of routers are there. They are connected to each other and they are providing a communication facility to the host computers. Now, I can use the term, I will be using the term host computer also for representing users. Okay, so these are the host computers. So if one host computer has to get connected to the network service, it is required to be connected to one router only. Okay, and by getting connected to this one router, it will come into connection with the whole network and all the host machines on the whole network. Okay, so just one connection is required. And this connection will provide the complete connectivity. So instead of one-to-one connection between, so say suppose I want to connect this, connecting it to this also, to this also, to this also, that is not feasible. Okay, it's going to be very expensive, plus it may not be practical also because distances are wide. It's wide area network and distances are very large, very big. So it's not possible to have direct connectivity between the computer. So in order to have them connected to each other, we provide a communication subnet. And this communication subnet is based on this store and forward or switch technology. We also call it switch technology. We also call it point-to-point technology. Why? Now this computer A wants to communicate with H. So transmission will take one hop. Okay, point, next point, next point, next point, and the final destination. So it is taking hop point to point, right? That's why the name point to point, then store and forward. So whatever transmission means here data is being transmitted. So data is transmitted at this point, it is stored, it is checked for errors. And then because now we can see that one path which I have highlighted over here is this one. Another path can exist like this. Another path can exist like this. So another path can exist like this. So because of this connectivity, a number of alternative paths are available. Okay. So when the data is stored over here, some routing algorithm or routing process executes and the best possible path which is available is identified. That is what happens when you look into those Google Maps when you are driving. Okay, so the best possible path is identified according to various criteria. Okay, and accordingly a decision will be taken as to whether to forward it to this point or to this point or to this point. Okay, so we call it store and forward. And this process is known as switching. We will be talking about this term more than once later on also. So this process, the data coming from here to here, then going to this point, then going to this point, this procedure or process is known as switching. So it is also known as switched transmission technology. So this is mostly followed in wide area networks. Means networks that are spread over a wide geographical area. Then we have broadcast transmission technology or multi-point technology. Broadcasting term, I hope you are aware of this term, as we have broadcasting in our radios and televisions, where transmission is taking place from one point, one station, and everybody is able to hear that transmission. So that is broadcasting. So here, one computer is transmitting, all the other computers connected to the network are receiving. Here, this thing is not there. This computer is transmitting, it will go to this only. Okay, from here it goes to this only. From here it goes to this only, and from here it comes to the destination. So the rest are not able to hear what is being transmitted. They will not receive what is being transmitted. Whereas in this case, one is transmitting and all the others are receiving. How can this be possible? Okay, so that will be possible according to a specific design with which we are deploying the network or implementing the network. So this design consists of here. You have got one single link. We call it a communication channel. So this is one single communication link. All the computers are connected to this single communication channel. So we have mainframes, we have workstations. Practically nowadays we have servers. So this is a server. Okay. A router which is connecting this network. This is the local network. This router is connecting this network to the internet. Okay. So we have routers and we have the host machines or the workstations or user machines. In this case, if one host machine transmits, it will go on all the signals which are created will travel through the whole communication channel. And everybody that is connected to that channel will be hearing the transmission. So I hope you got it. One is transmitting and all the others are receiving. Now, suppose this is transmitting something for this station, but everybody is receiving it. So how this problem can be resolved? So the thing is, whatever is being transmitted is transmitted in the form of a unit of data. So this much part is the data. And here we have got some control information in which one part is the source address, one is the destination address. Means who is sending the data, to whom he is sending the data. Okay. So every computer will be receiving this unit. And the very first thing they will do is look into the destination address in this unit of data or packet. We call it packet. Okay. So it will check the address here. If the address belongs to that particular computer, it will pass it on to the main memory and from where the main processor, etc., where it will be processed. In the rest of the computers, it will be ignored. When they will check the address and they find that this address does not belong to them, they will just ignore it. For example, in a class, if I say roll number 10 has to do this thing, everybody is hearing, but everybody knows that this job has to be done by roll number 10. The rest have to ignore it. So that is the strategy behind this technology. Now we talk about the categorization. So we are going to talk about categorization based on size and based on purpose. And while talking about these technologies, we will also talk about technologies means the categories of networks. We will talk about the size. Size means how much area they are covering. Second thing is we will also talk about the transmission technology which we have discussed just now. And we will also talk about topologies. Topologies means the interconnection structure in a network, how computers are connected to each other. Okay, they are the topologies. For example, here it is switch network. So there can be various possibilities of connecting these routers together. Here we have a broadcast network. Here I have shown a single cable to which the computers are connected. If it is a wireless transmission, then also it is broadcast. The single transmission media is the air through which transmission is taking place. Okay, so that is also broadcast. There are other ways also to deploy a broadcast transmission technology. Okay, so we will be categorizing these different kinds of networks based on those criteria also. And then based on purpose. Purpose means for what purpose the network has been established. It can be a wide area network, it can be a local area network also. So first of all, we have the personal area network. This is the first category we will be talking about, the personal area network. This is a very small network, small sized network, which is organized around an individual person in a small office or residence or any particular location, maybe within a car also. Okay. So here the objective is to establish communication among personal devices. For example, I have the laptop and I have my phone. I have captured some photographs in my phone, and from my phone, I want to transmit them to my laptop. So I keep my phone near my laptop. I make use of one of these technologies, for example, Bluetooth. This is the most common technology which we make use of. So using this technology, I transmit those photographs or videos or whatever in my computer wirelessly. Okay. So most of these technologies are wireless technologies. So they include wireless computer keyboards, mouse, Bluetooth enabled headphones, wireless printers, TV remotes, etc. Examples of personal area network technologies are Bluetooth, the most common one. Then we have Zigbee, we have Vibri, infrared data association. Infrared means here communication takes place through infrared waves. Here the communication is through radio waves, through radio waves, through radio waves. I will be talking about these kinds of waves, means the wireless media, wireless communication strategy, which is taking place in the air. We call them waves. Okay. So we have radio waves, we have microwaves, and we have infrared waves. Okay. So these are based on radio waves, the most common ones, which we use on our phones also. And this is based on infrared. So every kind of, every these kind of technology, it is using different spectrums, different bandwidths of the radio waves so that they can work independently. And in infrared, this setup, we do not require any kind of licensing or whatever because infrared has got its own properties. Okay, we will be talking about its properties in the second unit. So there are certain limitations. Okay. Then we have RFID technology, radio frequency identification, which is used in your tolls where you have your tags on your cards and you cross a toll and your tag is red. That is RFID. An example of RFID is being used in a number of applications nowadays. Then you have near field communication, wireless USB, and ultra wideband technology. Then we talk about local area networks. So these are networks which are limited in geographical area. So devices will be deployed only in a small area. So not as small as a personal area network. In a personal area network, two devices should be in a range of a few centimeters. Okay. Whereas in local area networks, a little wider area is covered, but still it is small. So what wider area? It can be a home, it can be within a school, it can be in our university, it is there in our university, in colleges, etc., and labs, in offices, etc. They can be wired also, they can be wireless also. I'll give examples of these. They are high in speed. High speed means the speed with which the data is being transmitted. And they are relatively low in cost. When we talk about this term relatively means as compared to other kinds of networks. So the cost is low over here and data transmission is fast. Naturally, when the area is small, transmission is going to be fast. Okay. Say normally they use only one type of transmission media. As I told you in the broadcast technology, uh, one type of transmission media means if it is based on wireless, it will be using wireless. If it is based on wired, twisted pair cable, it will be based on twisted pair cable. We will be taking some. So I'm usually it happens. Okay, usually means most of the time it is on one transmission media, but if we want to have combinations also of wired as well as wireless, that can also be possible. Then it depends upon our requirements. कैसे हम establish करना चाहते हैं, क्या requirements है हमारा physical layout जो है जहाँ पर हमने network को deploy करना है, वो environment क्या है. Then transmission technology used is broadcasting. So यहाँ पर broadcasting से the data is being transmitted. As I talked about this thing, one type of transmission media means single communication channel is being used. And then design issue. Now one design issue is this one, transmission technology, which is related to transmission technology. There are some other design issues also which are required for establishing communication between the computers in a network. So those design issues define the architecture of the network. So one architecture is the infrastructure, how we are connecting the computers together. Second thing is how those computers are communicating. One is on the cables, ones and zeros are being transmitted in the form of signals. Other thing is how those signals will be interpreted by the receiver. रिसीवर को पता क्या कैसे लगेगा कि ये इतने सारे वंस और जीरोस आ गए, इससे इंफॉर्मेशन क्या बन रही है. ओके, सो दैट डिपेंड्स अपॉन different kinds of design issues which are required to implement the complete network. So most of these design issues are related with software. Okay, so we have the hardware architecture also, that is the infrastructure. Second thing is the software architecture. So design issues here relate to the software architecture. So particularly in this case, we will be talking about all the design issues in the second presentation. So here we are going to characterize the networks also. So a particular characteristic of this kind of network where we are having a single communication channel and supporting broadcasting technology, one of the problems can be, as I told you, on the network, so many machines are connected. If one transmits, all the others are receiving. But if one is transmitting and the other also gets ready to transmit at the same time, how this machine is going to know that others are also transmitting? It will also start the transmission. So more than one machines on the network can start transmission at the same time. So if such a thing happens, there will be conflict. For example, if so many students are there, one teacher is teaching, the teacher asks some questions, more than one students know the answer, they start speaking at the same time. And the resultant will be a collision between the whatever they are speaking, and the teacher will not be able to understand what they have said. Okay, so we need an arbitration mechanism in such a case so that if conflicts are occurring, they should be resolved. Now, conflicts are occurring because of simultaneous transmission over the single media. Simultaneously, multiple transmissions are taking place from multiple devices. Okay, conflicts can be there, we call them collisions, and we have to follow a mechanism so that these collisions can be resolved. Okay, that mechanism is an arbitration mechanism, and as a design issue, the technical term which we use is media access control. This is the technical term which we are using for this process. So this is one of the pertinent design issues. Why we are mentioning it over here? Because local area networks are based on broadcast technology. So this design issue will be applicable to local area networks only. But when we talk about wireless communication in a wide area network through satellites, Okay, that is a wide area communication over a wider area. There also we make use of arbitration mechanisms. So I'll talk about that later on. These are the components of a local area network. We have computers or printers and other devices like these. Then we have some powerful computers which we call servers, like this is a server. Okay, we have the printers, we have computers. Then there will be a communication channel which is connecting the computers together. This is the channel. Then there will be a network interface card. This is also known as an adapter or a LAN card. This network interface card is installed inside the computer and it provides an interface of the computer with the network. जो ये केबल के साथ कनेक्टेड है, ये केबल से जो सिग्नल्स जा रहे हैं वो कौन रिसीव करेगा यहाँ पर, जो इंटरफेस बना हुआ है यहाँ पर, who is going to access, which is going to have the receiving of the signals and then identifying whether this is my address or not. Should I process it? Should I give it to my memory and my processor for processing it? That will be done by the network interface card. Okay, we'll talk about this in more details later on also. Then there can be one or more switches or hubs. So this is a device, because this is one of the, earlier I talked about one single cable. This kind of topology is known as a bus topology. Topology, as I told you, interconnection structure of the computers in a network, how the computers connected to each other. So this topology is bus topology. This topology is a star topology. Again, I'll go into a little bit more details in this very presentation in the upcoming slides. So this is one device through which we have a star topology. Okay, but transmission will be broadcasted. Broadcasting ही होगी, लेकिन यहाँ पर अभी ये बस नहीं, हमने एक device use किया है. This device, nowadays it is a switch. Earlier it used to be a hub. Hubs are used nowadays also, but very rarely. Okay, so I'll talk about their differences also later on. And then we have an operating system. Naturally, the operating system should be able to support networking communication. Okay, so in a local area network, we can have novel network or Windows. With Windows operating system, we have this Windows 2000 server operating system. We can have Linux also installed. We can have Unix also installed. So there are other operating systems also, but these are the most commonly used ones. Then characteristics of LANs, the data rates can range from 4 to 16 Mbps, because in a local area network, the transmission, the kind of transmission which we are doing does not require very high speeds. Earlier, I will not talk, I'm talking about the earlier scenarios where LANs were used, but nowadays applications have grown a lot. Within a company, now say, as we are having this online class, okay, I have my connection to the local area network. You might also be having your connection through the local area network. Your local area network is connected to the wide area network, the internet. Okay, so local area network here I am using is a wireless network, which is Wi-Fi in my home. Okay, so in order to have a speedy, we are communicating through a video conferencing meet. Okay, speeds are a must here. Speed बहुत high होनी चाहिए, because videos का transmission जो होता है, it is consisting of videos consisting of thousands of frames. Continuity में there are thousands of frames which are displayed to create the video, and these thousands of frames, each of the frame consists of one shot of picture taken in a fraction of a second, and one of that picture is made out of thousands of bits, because picture जो आ रही है वो colored है, ठीक है, और thousands of bits here means पूरी picture जो होती है एक raster में बनी होती है. In your fourth semester you will be studying this computer graphics paper. So thousands of pixels are there, we call them picture elements. बहुत points से बनी हुई होती है picture. हर एक point जो है वो किसी भी color से display कर सकते हैं. For example, here I have used red also, green also, black also. So many colors are there. So every color requires a different code. So if there are suppose 16 colors, 16 is just a very small color, there are millions of colors. With 16 colors, I will require 4 bits to code one color uniquely. एक कलर को यूनिकली कोड करने के लिए मुझे 16 बिट्स की 4 बिट्स की जरूरत है. 4 बिट्स यूज करके मैं 16 कलर्स से डिस्प्ले कर सकती हूँ कंटेंट. So I can display with 16 colors. So you can very well imagine the complete size. First of all, the size of this picture. Suppose the complete size, we define it in terms of resolution. So the complete size is suppose 10 to 4 by 10 to 4 pixels. And every pixel is requiring 4 bits for its representation. So you can very well imagine the number of bits required to code one frame. And here we are having thousands of frames. Transmission should be very, very fast. Then only we will be able to view each other in real time. मेरे को real time में आप view कर रहे हो कि किसी की आशीष कुमार है, इसने अपना जिमली use किया हुआ है ना. So very nice looking very smart. I don't know whether really he's wearing a cap or not, or it's a real Ghibli of Ashish, but looking good. So you can very well imagine the real time when we are communicating, we require very high speeds, and now we have speeds that can range from 100 to thousands of Mbps. Okay, we call them gigabit. This is fast Ethernet. Basically the networks by default nowadays, the networks, the kind of networks which we are using are Ethernet LANs. So 100 to 1000 to 10,000 Mbps, megabits per second of speed can be attained. Local area networks are normally privately owned. Privately means either I am owning it in my home, or I have it in my university, in my department, in my lab, which is meant for the students to work on it. So it is privately owned by my department, or it can be owned by a campus. छोटा सा campus है, school का या college का LAN establish किया, so that is privately owned. And typical, naturally privately owned, and hence typically it is used for single sites. Single site पर ही ज़्यादातर होता है. And then it can be entirely wireless also, it can be entirely wired also, it can be a combination of both also. Then common topologies which are used are bus, ring and star, which we will talk about. And then common LAN standards which were used earlier. ARCANET, token bus, token ring, etc. But the current technology nowadays for local area networks is 802.3 Ethernet LANs over twisted pair cabling. This is used with star topology using switches. Okay, so with wired networks we have this Ethernet LAN, and with wireless network we have Wi-Fi, wireless fidelity. So these two standards are the most commonly used standards nowadays. So this is a depiction of local area network where we have a switch. Depiction means what we are having nowadays. Okay, so we have a switch, and to this switch we connect all the devices together. So all communication, if somebody is transmitting, it will go to all the others. Particularly with the switch, everybody can transmit at the same time. There will be collisions. We will be using a media access control mechanism, but switch, as it differs from hub, switch identifies the destination address itself. It's intelligent in nature. It identifies the destination address and will forward the data only to that particular destination. For whom? it is meant. So that is why switches are now being used most commonly, because the sizes of local area networks have also increased. Size means increasing in terms of number of users. So we need to have fast speeds. For fast speeds, we do not want others to be disturbed if the data is not meant for them. अब इसके लिए डेटा मेंट नहीं है, लेकिन इसको भी इसने भेजा हुआ है, इसको भी मिल रहा है, ठीक है? So naturally it is going to get disturbed. So that will slow down the speed. So within a building, this is the geographical area it is covering. So it can be on the floor of one building, it can be in a room, etc. Then this is the bus topology for local area networks. I talked about it earlier also. A single cable is there and computers are connected to this single cable. The connections again depends upon the kind of standard of Ethernet LAN which we are using. This drop line is used in 10 base 5 Ethernet LAN, where we have these vampire taps, we call them vampire taps. There is a transceiver, which is a box within which we keep the wire, and it's a clamp type box, and we just press it. Okay, so wire comes into connection with the pin that is there in the box, and whatever signal is going on in the wire, it comes to the computer. So, but as I told you, this is with bus topology. Nowadays, we do not use bus topology. It is difficult to configure. पूरा इसका setup करना थोड़ा सा difficult होता है. With a switch, it is very easy to establish the local area network. So it's easy to install, uses less cabling, single cable use करके हमने कर लिया तो easy है install करना. Easy है लेकिन not as easy as a star topology. But sometimes configurations and fault isolations may become difficult. So suppose the network stops working, it will be difficult to identify the fault as to where the fault has occurred. यहाँ पर हुआ या यहाँ पर हुआ, ये सारे के सारे points check करने पड़ते हैं. So that becomes a little bit difficult. So this is these are the examples of LAN standards which are based on bus topology. Ethernet LAN 802.3 Ethernet LAN standards, and this is 10 base 5 I talked about just now. We have 10 base 2, 10 base 5. Okay, so and the third one is token bus 802.4. So these are IEEE standards, and each of the standards uses a different kind of wire. So 10 base 2 uses a thin wire, thin coaxial cable wire, and the connectors are also different. 10 base 5 uses different connectors. I'll talk about these later on. So here I'm talking in the context of just as an example of bus topology. Then we have the ring topology. Here the computers are connected in the form of a ring. So in a bus, both ends were open. In a ring, both ends are connected. So this forms a ring. कहीं पर भी कोई termination नहीं है. It's complete. Okay. So it's a circle with no ends. And here every device has got a dedicated connection like this. So connection is point to point. We make use of twisted pair cables. Connection is point to point, but transmission is broadcast. So एक cable यहाँ इन दोनों को connect करने के लिए, one cable for connecting these, one cable. So these are all different cables. Okay. So there is a point to point connectivity, but it's a local area network, not a wide area network. However, a wider local area network can be established, but transmission is going to be broadcast in nature. If one transmit, the whole transmission will go through the complete network. पूरी ring पर पूरा transmission जाएगा जैसे बस में जा रहा है. So it is broadcast in nature. So in our third unit, we will have the IEEE 802.5 token ring LAN. I will talk about the practical implementation of this in the third unit. So again, advantages and disadvantages are nearly the same. Easy to install and reconfigure. because with twisted pair, it's always easy to install, because the kind of connectors which we are using, just click on the that connector and your computer is connected to the network. Here again, if there is a break in the link, it will, in the ring, it will disable the entire network. So this is an example, 802.5 token ring LAN. So this is how this token ring LAN is deployed. Then we have the star topology about which I was talking. This is a switch, this orange one, and this is a hub. The difference is hub is passive in nature. If one transmits, it will forward the transmission on all of these. But in a switch, if one transmits, switch is active in nature. It will first check the address of the destination and will forward it only to that machine. It will not disturb the others. Rest of the things are in the software, they are the same. Rest of the protocols are the same. So we call it a star topology because we have this single communicating device, network device, and all the computers are connected to this single one. So the shape looks like a star. So again, it's very easy to install and reconfigure it. It's robust in the sense that if there is a fault here, इस सिस्टम के साथ फॉल्ट हो जाती है, बाकियों को कोई फर्क नहीं पड़ेगा. But in a ring topology and a bus topology, the communication may be affected. And if we extend the star topology, it becomes tree topology. So here we have one hub. To one of the ports of the hub, add another hub. And then we have the computer. So it's extended over multiple levels, and we call it tree topology. So advantages and disadvantages are similar as that of star topology. So this is how 802.3 Ethernet LAN standard 10 base T, 100 base T. 100 base T is fast Ethernet. T here means using twisted pair cable. So this is the Ethernet switch using twisted pair cable to one of the ports of this switch. We connect a printer, we connect a computer, a server, another server, like this. So this is how star topology is implemented. This is a local area network with internet access. ना इसको एक्सटेंड आप कर सकते हो, कैसे फैसिलिटीज इसकी हम अटेन कर सकते हैं. So if anybody from the authorities of the LMS system is present, please don't cut this connection till I finish the lecture. So this is these are two local area networks. A local area network is generally represented using bus topology so that at a glance we come to know that it is a local area network. मतलब देखते ही हमें ये लगे कि लोकल एरिया नेटवर्क है क्योंकि ये बस टोपोलॉजी यूज करी हुई है. बट ये बस टोपोलॉजी एज सच, जैसे एज आई टोल्ड यू अर्लियर, इट इज नॉट यूज्ड नाउअडेज. सो टू दिस ब्रिज इज अ डिवाइस व्हिच कनेक्ट्स मोर देन वन लोकल एरिया नेटवर्क्स टुगेदर. एक से ज्यादा लैन्स को कनेक्ट करने के लिए यूज होता है. सो दिस इज वन लैन, दिस इज वन लैन, एंड दिस ब्रिज इज यूज्ड टू कनेक्ट द लैन्स टुगेदर. सो हियर वी हैव शोन दैट एक्चुअल connection is through a switch. Here also the actual connection is through a switch. To one of the ports of the bridge we have connected one switch. Here also to one of the ports we have connected a switch. To this switch here these computers are connected. And one of the ports of this bridge is also connected, or of the switch is also connected to a router. And the purpose of the router is to provide internet connectivity. This router is installed by the internet service provider. So through this router, all devices in this local area network will be able to access the internet, as well as users on the internet can have access to this LAN. And because we have connected this LAN also with the bridge, so all devices on this LAN also will be able to have access to the internet. So in this LAN, through this switch, we have the normal computers. We have a wireless access point ये वाईफाई के लिए जो हम लगाते हैं यहाँ पर, वैसे तो ये जो घरों में होते हैं, आपका जो स्विच होता है, that is acting as a switch as well as a router. Basically it's a router and it is equipped with wireless access point also. अलग से नहीं होता, बट जहां पर थोड़ा बड़ा वाईफाई होता है, like it's there in our university, so the switch extends wireless access points to different locations. So this is providing wireless access, so devices can access the network wirelessly also. And further to this, to extend the network to this switch, we have connected one hub, and to this hub now these three devices are connected, although they are connected to the single hub, but they are in connection with the whole network and in connection with the internet also. So this is another possibility with local area networks. And we also have home area networks, घर में जो हम install करते हैं, and these are the different kinds of devices which we can connect in our homes. And here we can have different kinds of connections. Nowadays we have the fiber to the home, but we have the broadband connection also, possibility of broadband connection also, ADSL, asynchronous digital subscriber line. Okay, so we have over here the connection through the internet to a router, which acts as a hub also, which acts as an access point also, and which also acts as a modem also. Okay, and with this now we can have wired connection also. ये client computer है हमारा, desktop computer, we can connect it through a wire also, and we can have wireless connections also. Both options are there. And this is a wired home area network where we have connected all devices through wires. Here through the internet, we all also install this. Firewall can be installed at the service provider side also. We can also have this firewall in our routers. Okay, so a firewall is a security device which can restrict certain kind of information to enter our network. We can also set up security mechanisms for particular kind of data to not go out of the network. अंदर भी ना आ सके और अंदर से बाहर भी ना जा सके. So we have the ADSL connection here, asynchronous digital subscriber line, and through that we have connected a number of devices. And this is wired and wireless, a combination in an organization. We have the firewall, router, and this is a Wi-Fi router, which is providing wireless connections to a number of devices. And this is a switch. This is providing wired connections. So connections to servers. So if it is in an organization, servers are connected through wires because wireless provide higher speeds of communication as compared to wireless connections. And this is Wi-Fi. It operates in two modes. One is independent mode, in which no infrastructure is there, no access point. Directly the devices can communicate with each other. Normally in regions like military operations, where it's not possible to lay down an infrastructure, such kind of mode is used. And then we have the other one, which is infrastructure mode, where we have the access point, and this access point supports wireless connectivity for the devices. This access point is connected to a local area network, as we talked about earlier, that it is connected to a switch. And this is a campus Wi-Fi network like we have in our universities. So here we have the main core switch, to which further we extend, because a wider area, wider means a campus wide area has to be covered. तो वो जो range होती है Wi-Fi की इतनी ज़्यादा नहीं होती. तो कैसे extend करते हैं हम range? जो core switch है जिससे internet connectivity आ रही है, to that core switch we connect further switches. To these switches we connect access points, and these are very fast gigabit switches normally. And to these switches we can extend the switch further to another switch, and then to further access points. I will talk about two options. I just named them. HyperLAN, this high performance local area network, is very costly, not used nowadays. It was prior to the advent of this Wi-Fi networks. So now Wi-Fi networks are more common. So it is very high in speed, and hence it's costly also. So it provides very high speed support to ATM networks or mobile networks or IP-based networks, and is capable of, at that time it was capable of transmitting video, voice, etc. Nowadays, Wi-Fi is also supportive of all these types of communication. Then another is home RF. These are the different kinds of wireless local area networks. So this is particularly used for home purposes, where your home device is cordless handset, and nowadays it is not prevalent, not used. तो वाईफाई से पहले घर में वायरलेस कनेक्टिविटी के लिए यूज होता था. So I will stop now. I'll continue with this tomorrow.